Friends, welcome to the class. Today we'll discuss about section formula. Section formula is of two types: internal division of a line segment and external division of a line segment. Let's start with internal division of a line segment. What does it state? Let a x1, y1 and b x2, y2 are the 2 points, and b x, y is a point on the line segment joining a and b, such that AP is to BP equals to M1 is to M2. Then the point P is set to divide the line segment internally in the ratio M1 is to M2. Let's draw the picture. So as it is clear from the picture, the A x1, y1 and B x2, y2 are the two end point of the straight line, and there is a point P in between the line segment Px, y, which divides A and B in the ratio M1 is to M2. That means here PA is the length is M1 and the length of PB is M2. Now, how to get the coordinates of P? The coordinates of P is given by m1x2 plus m2x1 whole divided by m1 plus m2, comma m1y2 plus m2y1 whole divided by m1 plus m2. Now let's see external division of the line segment. If a point px, y externally divides the line segment AB in the ratio m1 is to m2, then the coordinates of P is given by m1x2 minus m2x1 whole divided by m1 minus m2, comma m1y2 minus m2y1 whole divided by m1 minus y2. And the picture goes like this. So here it is clear. The line segment AB is this much, whereas the point P lies somewhere outside the line AB. Now PB, the length of PB is m2 and the length of PA is m1. That means we can say that P divides the ratio, P divides the line AB in the ratio m1 is to m2. And in this case, the coordinate of P is given by m1x2 minus m2x1 whole divided by m1 minus m2, comma m1y2 minus m2y1 whole divided by m1 minus m2. Now it has some special cases. If a point P divides the line segment joining the point A x1, y1 and B x2, y2 internally in the ratio 1 is to 1, that means if the point bisect the line, then the coordinates of that particular point is given by x1 plus x2 whole divided by 2, comma y1 plus y2 whole divided by 2. Or in other words, if the coordinates of the two endpoints of a line segment are x1, y1 and x2, y2, then the midpoint of that line segment is given by x1 plus x2 whole divided by 2, comma y1 plus y2 whole divided by 2. If the ratio in which P divides the line segment AB is k is to 1, then the coordinates of P is given by kx2 plus x1 whole divided by k plus 1, comma ky2 plus y1 whole divided by k plus 1. Let's see some examples. Find the coordinates of the point which divides the line segment joining the points 3, 4 and minus 5, minus 7 internally in the ratio 2 is to 3. Let Px, y is the record point which divides the line segment, say A 3, 4 and B minus 5, minus 7 in the ratio 2 is to 3. So here m1 by m2 equals to 2 by 3, x1, y1 equals to 3 by 4, 3, 4 and x2, y2 equals to minus 5, minus 7. We know in case of internal division, the coordinates of the point of division can be given as m1x2 plus m2x1 whole divided by m1 plus m2 and comma m1y2 plus m2y1 whole divided by m1 plus m2. So putting the values of m1, m2, x1, x2 and y1, y2, we get px, y equals to 2 into minus 5 plus 3 into 3 whole divided by 2 plus 3, comma 2 into minus 7 plus 3 into 4 whole divided by 2 plus 3. That equals to px, y equals to minus 1 by 5, comma minus 2 by 5. So the record point is minus 1 by 5, comma minus 2 by 5 is the answer. The midpoint of the line segment joining A 2a, 4, B minus 2, 3b and is 1, 2a plus 1. Find the values of A and B. So in this question, the two endpoints of the line segment is given and the midpoint of that particular line segment is also given. But it contains some variables A and B which we need to find out. Given points of the line segment are A 2a, 4, B minus 2, 3b and the midpoint is 1, minus 2a plus 1. Now we know that the coordinates of the midpoint of the line segment joining the points x1, y1 and x2, y2 is given by x1 plus x2 whole divided by 2, y1 plus y2 whole divided by 2. So the midpoints of the AB can be written as 2a minus 2 whole divided by 2 plus 4a plus 3b whole divided by 2. Or we can write it as 2a minus 2 whole divided by 2, 4 plus 3b whole divided by 2 equals to 1, 2a plus 1. Now equating the x coordinates with x coordinate and equating the y coordinate with y coordinates, what we get? It's 2a minus 2 whole divided by 2 equals to 1 and 4 plus 3b whole divided by 2 equals to 2a plus 1, or 2a minus 2 equals to 2 and 4 plus 3b equals to 4a plus 2, or 2a equals to 4 and 3b equals to 4a minus 2. So a equals to 2 and putting the values of a we get 3b equals to 6. So a equals to 2 and b equals to 3. Hence the values of a and b are 2 and 3 respectively. In what ratio does the point minus 4, 6 divide the line segment joining the point A 6, minus 10 and B 3, minus 8? Let the point P minus 4, 6 divide the line segment joining the point 6, minus 6, 10 and B 3, minus 8 in the ratio k is to 1. We know if Px, y divides the line segment joining A x1, y1 and B x2, y2 is k is to 1, then the coordinates of P is given by kx2 plus x1 whole divided by k plus 1, ky2 plus y1 whole divided by k plus 1. So here we can write 3 into k plus minus 6 whole divided by k plus 1, minus 8 into k plus 10 whole divided by k plus 1 equals to minus 4, 6, or 3k minus 6 whole divided by k plus 1, 10k minus 8, 10 minus 8k whole divided by k plus 1 equals to minus 4, 6, or on equating the x coordinates on both the sides we get 3k minus 6 whole divided by k plus 1 equals to minus 4, or 3k minus 6 equals to minus 4k minus 4, or on solving we get k equals to minus 2 by 7. Now k equal to minus 2 by 7 we got by equating only the x coordinate 3k minus 6 whole divided by k plus 1 equals to 4. Now we need to check whether k equals to 2 by 7 justifies the y coordinate or not. That means 10 minus 8k whole divided by k plus 1 should be equals to 6. Let's check that one. Putting y coordinates on both the sides, we get 10 minus 8k by k plus 1 equals to 6. Let's put the values of k. In y coordinates, we get it is 10 minus 8 into 2 by 7 divided by 2 by 7 plus 1, or it is 10 minus 16 by 7 whole divided by 9 by 7, or it is 70 by minus 16 whole divided by 7 by 9 by 7, which is equal to nothing but 54 by 9, which is equal to 6. So k equals to 2 by 7 justifies the y coordinates. Hence, the point minus 4, 6 divide the line segment in the ratio 2 is to 7. Friends, here we saw a few examples of section formula. In the next class, we will discuss more about section formula, the classification of section formula, and what all question may come across pertaining to section formula. So this was for today's class. Thank you.